Okay. Thanks for joining, everyone. Thanks for giving me some of your time so we can review together the titration curves. So, hope you are okay and you are doing well in your study. Stay strong. I know it might be tough and the time is short, but you are up to it. So, do your best and then leave the rest to the God. Okay. Titration curves, the first part is just an introduction, and we are trying to know what's happening over here. See. Okay, so the section number one is introduction just to the titration curves. What is titration? Titration is a laboratory technique used to determine the unknown concentration of a solution by reacting it with a solution of known concentration. So I have two solutions here. I have one solution which I don't know its concentration, and I have another solution which I know its concentration. So let's imagine that this is the first one. I know its concentration, and this is the second one. I don't know its concentration, and let's make it in a different color. So both of them are test tubes. So here I don't know its concentration, and here I know its concentration. And this is solution one. I know its concentration. So what about the volumes? Don't worry about the volumes. One of them, I know its volume, and one of them, I will not know its volume at the beginning, but after that, it will be known by the end of the titration process. So think of it like pouring a lemon juice into milk. So imagine that you have a cup of milk, and then milk should be white, right? So milk, and then you put some lemon juice on it. So you bring a lemon or lime, and then put some of the lemon juice inside. The acidity changes affect what happens next. But in titration, instead of guessing, we measure these changes accurately with a pH meter or indicator. So the first question, titration is used to identify the color of the solution? No. Measure the temperature of a liquid? No. Okay, and determine the concentration of unknown solution? Yes. So I will use it to find the concentration of this solution. Find the mass of solute? No, this is not correct answer. So the answer is C, but what is a titration curve? It's a curve or a graph that shows how pH changes as the titrant is added to analyte. What is the titrant and analyte? You remember we have the two test tubes? Yes, we have the test tube with the unknown solution concentration and the other test tube with the known concentration solution. So let's start by the first one. The first one that I don't know its concentration and it's being analyzed, is going to be called analyte. The other one that I already know its concentration, known concentration, is known as the titrant. So I add the titrant to the analyte so that I can know the concentration of the analyte. So now I'm going to make a curve or a graph, and the graph will show me what happens as I start from the experiment at the beginning and I don't know anything about the analyte, and the pH of the solution is going to change with time. So this is x-axis time, and this is the pH of the solution. Let me see, is it going to increase? Is it going to decrease? What's going to happen? Is it going to increase and decrease? What's going to happen? This is called the titration curve. So this is called the titration curve. So on the x-axis, again, I plot the volume of the titrant added. So not the time only, I will put what is the volume of the titrant added. Remember, I add the titrant to the analyte. I add the titrant to the analyte. So if there is no titrant added, this is time 0. Then I start adding 1 ml, 2 ml, 3 ml. And on the y-axis, I'm going to put the pH of the solution that's formed by putting number 1 on number 2. So this is going to help me visualize where is the reaction happening fastest, how much titrant is needed to know where to stop, and the pH difference. So what was the pH at the beginning and at the end, and like that. So question number 2, what does the x-axis represent in the titration curve? We said not the pH of the solution, not the molarity of the base, not the number of molecules, The answer is that the x-axis is the volume of the titrant added. Don't be afraid from the curve. If you just divide it into three parts, it will be very easy. So I first start adding one solution, and this is its volume, and then the pH of the total solution I will know. This is a flask. It's a good time to say that I have a flask here. Let's say I will put some HCl, and this HCl, I know its concentration and I know its volume. I have added a certain amount of volume and I know its concentration. And then I'm adding another solution here from the top. So let me add the first solution here from the top. I don't know yet how much the volume I'm gonna use, but by the end of the experiment, I will know how much. And I don't know the concentration. So by the end, I will know the volume, but I don't know the concentration. So what is the concentration? So let's say I stopped here, then I will know I have changed it from 0 into 30, so I have used 30 ml. So I'll be knowing the volume of this one, but I don't know the concentration of this one, and I already know the volume and concentration of these two. So the volume keeps increasing slowly. I am adding, so since 0, I did not put anything at the beginning, and then the volume starts to increase. The initial region before the titration starts, this is where only the analyte, unknown solution is present. And the pH determined by the analyte alone whether it is an acid or base. So if it is an acid, if there is an acid here at the flask, the pH is going to be a low pH. So we know that acids have low pH less than 7. So if you started with the analyte, the pH is going to be low. And then after that, the buffering region. The buffering region, there is a gradual pH change. So the pH is going to change, but not suddenly. If you did the graph, draw it like that, this means that's a sudden increase, and this means that it is a slow increase. So the difference, if the very steep curve means it's a sudden increase, but a slowly steeping curve means that it is a gradual increase. It is a gradual increase. Why it is gradual? Because I'm having a buffer being made here in most of the curves. So this is a gradual pH change. If it is a weak, strong base titration, a buffer system is created here. Don't worry about this one. I will explain to you more in the correct place. Just know that the pH is going to increase. This is what I want you to know here. Then there is an equivalence point. There is a sudden pH change. It's a very steep curve, but it's a straight line here parallel to the y-axis. Why is that sudden increase in the pH? Because the amount of titrant added is exactly enough to the analyte. So here is the analyte and here is the titrant. The number of moles of them will be equivalent. Don't worry if you don't understand. I'm just trying to tell you the three parts of the curve. The amount of the titrant added is exactly equal to the analyte. The pH jumps rapidly in this region. And the last part, number 4, after the equivalence point, after the reaction has ended and they become equal, I start adding excess. So when I add excess, the solution becomes now depending on the top solution. So if this is an acid and I'm adding a base, so now it becomes a basic solution. So the pH starts to increase again into the pH of the base. So let's try to imagine it in this phase. The first one, the first thing, I have only the acid. So I have only the HCl, that's the pH is very low. So it has a low pH. And the second one here, I have neutralize it. So the HCl is equal to NaOH. So I have made a neutralization here. So I have the pH at 7, for example. And then number 3 here, I will be having the NaOH more than the HCl. Now it's not neutral anymore. Now it is basic. So the solution is going to be here at the basic region. Don't worry if you still don't understand, you are going to understand by time. This is happening in any difficult topic. If you don't understand, just keep moving slowly, slowly, you will understand by time. Okay, so the question number 3 is the equivalence point of titration. What happens? What happens is that the solution reaches boiling point. The amount of acid equals the amount of base. The pH becomes exactly 7 no matter what the solutions are used. The solution stops reacting. So we thought that the solution will be at pH 7. Oh, this might be correct in some of the types that we will take, but some will not be correct. So forget about being 7 always. This is not correct. But what is correct is that the amount of the acid will be always equal to the amount of the base at the titration end. This is called the equivalence point. The point at which the titration happens officially is called the equivalence point. So, what are the types? You are saying that there are types? Yes, there are types. I can have a strong acid reacting with a strong base. This will be first type of the titration curves. There will be a rapid pH rise here. Equivalence point at pH is equal to 7. If you remember, we said this is a neutral salt formed. So pH is equal to 7. The second type is where I will have a weak acid. So I will have a weak acid reacting with a stronger base. And the best characteristic is that there will be a gradual curve. And this equivalence point is above pH 7. So it is above pH 7 because the strong base makes it a basic salt, if you remember. And then the third type is that I will have a strong and weak base, strong acid plus weak base. So this means that the salt is going to be acidic salt. So this time that pH of the is less than the 7 at the titration, and this is also a gradual curve. Next, we will know what is the titration of polyprotic acids where is multiple equivalence point. Oh, I hear somebody asking, what about weak and weak? Weak acid and weak base, don't forget weak acid and weak base. Yeah, we are going to come to this also. The next question is asking which type of titration has multiple equivalence points. That will be the polyprotic acid titration. We'll take and understand this later also. I've been saying later a lot. Don't worry, this is what we will do always when we are studying any topic. How to analyze a titration curve? To read a titration curve, look at what? Where the curve starts. Where does the curve start? Did it start in a place where it is acidic? Is the pH very low here at the beginning, so it is acidic? Or it started at something basic? If it is a high pH, it started with an acid, and so you have in your flask an acid. If you have a high pH, it is a base. You started by putting a base in the flask, but if it started with a low pH, it is an acid. So you started by putting an acid here in your flask. The second thing to look at how the pH changes as the titrant is added. The steep vertical region, this is the equivalence point. Is this a sudden gradual change? Is this a gradual change or a sudden change? The final pH where the solution remains. What the solution remains is you are going to the base is a strong base, so that's why it's very high, or it is a weak base, so it's a little bit low, just higher than the 7. If the titration curve starts at a low pH, what does that tell you? It means that when you have started this reaction, you are having an acid at the beginning. So you are having an acid at the beginning. That's why when you started at a low pH. Let's see the answer of this one to make sure that our answer correct. Is it strong acid, weak acid, strong base, or the addition is done incorrectly? No, it means that I have done it correctly and everything is okay. But then the analyte is a strong acid. That's why it's a very low pH. So like 1 or 2 is the value that we are going to have. That's why it will be 1 or 2. Now, key takeaways, the titrations used to determine unknown concentration. A titration curve with a graph of pH versus titrant added. The equivalence point is added when the acid and base are completely neutralized and different titration types produce different curves. Analyzing the curve tells us important information about the reaction. And see you in the next video. If you like this one, just make sure that you see us tomorrow because we'll explain more about titration curves types.